Okay. Now talking of the I'll give an example of an airplane, of the airplane crashes. Well, there's one particular one that maybe I will also talk about. In fact, I remember it was in either the exam of the previous year. I think the exam of the previous year. I don't know if it was the exam or something. Maybe it was an assignment. The incident of the two plane crashes of the Boeing 737 MAX. You probably know about those crashes. Does anybody know about those crashes that occurred? Two Boeing 737s, they occurred 2 months apart. Was it 2 months apart? I think, no, 6 months apart, I think.
Yeah, the one of Ethiopian Airlines.
Yes, there was one of Ethiopian Airlines, and there was also one. Okay, good. You know about them. There was one of Ethiopian Airlines, and there was also one of where was this one headed? This one, I think, was. Anyway, one was Ethiopian Airlines, one was, I think, was it Indonesia? Indonesia? I think it was Indonesia. Malaysia, yes, Malaysia. Oh, was it Malaysia? Malaysia? Okay, I'm just trying to remember. No, but anyway, one of those countries. So these two crashes, if you know, this is why it's very important to study some of these things and take them seriously. Because in the end, so many people lost their lives. And all because, okay, not all because, but partly because of chasing profit. Very, very unfortunate. So, you know, there are two very big airline manufacturing companies. There's Boeing, and there is it Airbus?
Yeah, Airbus.
It's an Airbus. Now, these are always competing. They are always competing, always trying to, you know, make planes and sell them to different airline companies. And then now the Boeing with this 737 MAX was really trying to make sure, but they always try to make sure that these things are fuel efficient. That's how they manage to save. That's one of the ways they manage to save money. So in trying to make the 737 MAX fuel efficient, they developed engines that were not as easy to manage as the previous ones. Okay, so their positioning, they had to position them slightly different on the airplane compared to the previous positions. Now, this slight change in position caused, also caused, the plane cannot have the same lift, okay? What's that principle called? I've forgotten its name. And then it can't lift in the same way. So in order to manage the lift, because now in this case, when those engines are changed, their position and even their weight changes, you're probably going to have the plane get maybe steeper easily, or okay, the steepness is affected as it's climbing. As it's climbing, I don't know if you've any of you have been on flights. I've been on a few. They're not really enjoyable. I think I'm more someone who prefers being on the land. But these, so to manage this steepness, they have a system called the MCAS. The MCAS is the Maneuvering Characteristics Augmentation System. So it's a system which they developed to manage this steepness of the plane as it's climbing, as it's descending, and so on and so forth. But now, in putting this system, they did not. First of all, they wanted this plane to sail quick. So they managed to convince some of the, now like in the US, they managed to convince what I can call it the skies management or the air management section in the government to allow them to sell them quick. And then they did not specify properly what this MCAS was like, how it worked, how it exactly worked. And you cannot always get away with something. So they didn't even do the necessary trainings. They didn't do the necessary trainings to the extent that is required. So what happens? The planes go, the planes are being used. And there were cases at first where the plane would billet, would go into the air. And then what this system does, when the system senses that the plane is trying to stall, this system tries to pull it back. So stalling is when a plane loses it reaches a steepness whereby it's going to just fall to the ground and crash. So it tries to pull the nose back. But now in doing this, in doing this, of course, if a pilot doesn't know about the system, it's very dangerous. Because if it's in an emergency, he will not know how to manage that system. And it's what happened with these planes. It happened that on these planes, there was a sensor which was giving wrong information. Now that's the problem. Now we shall see that as we're going on in some of the ahead. Faulty equipment can be very dangerous. So a faulty sensor fed wrong information to this system. Now, of course, this system, once it's fed with the wrong information, it will assume that information is what is happening. So it got the wrong information about the angle at which the plane was. Getting wrong information. Now imagine the plane is already in a correct position, but then the system receives information that the plane is at a wrong angle. Pull the nose down. Okay. So please mute in case you're not muted. So in pulling the nose down, it caused the plane to stall. And once the plane starts stalling, it's very, very difficult to control it. The pilots were unaware about this system, so did not really know how to counteract it. Okay, they don't know how to counteract it. So in that struggle, counteract it, because this system overrides the controls of the pilot. So they do not know how to deal with this system. It's supposed to be switched off, and then the pilots try to get a control of the plane. But anyway, what happened is the pilots couldn't control the planes, and the planes crashed. Very, very unfortunate. Just because of, not just, but partly because of chasing deadlines, chasing money. That's that compared to someone's life. There is a family. There is a man who was sending his family back to see their the grandparents. He lost the entire family, wife and children. So you cannot say that there's nothing that is equivalent to life, okay, when it comes to this. So it's better to be safe, better to work on safety. It's more important than the other things. And that's just one example, because it was one of the, either in the exam or something, sometimes it was just an example. So 40 sensors are the ones that exposed these people who failed to, and this is a system that could have been, that the pilots could have gotten training on, and they could have managed. Okay. Right. So let's just give you an example. It's a very clear and vivid example of why we have to be serious about safety. About safety. People's lives are at stake. Those are people's lives at stake when it comes to safety. either in the PDFs, yeah, in one of the PDFs I'll share, there will be another example of an Airbus which crashed on landing, and it killed it killed 2 people, it injured 54. And the cause of that was a failure of a control software, which made the braking system fail. So there can be those circumstances that come in here and there. Okay. Let me share the screen once again and we'll continue. Share screen. Share screen. Share screen. Okay, so yes, we're talking about a holistic design for hardware, software. They all have to be interconnected. Okay, they all have to be interconnected. Okay, you can't ignore one part, and then you can't ignore one part. Now, like how they ignored, they didn't train the pilots in the use of that. They just put the system there and hoped that you know, it would work like that. But another thing is training the pilots was very expensive. So probably even that one they were dodgy. Okay, I've seen the put first message, so that's fine. Yeah, training the pilots was also something they're trying to dodge in terms of the expense, but disastrous in the end. Everything has to be interconnected. The software and the hardware are there, the people are there also. All of them have to be aware of each other. Then the system will work properly. Okay, then I was saying that we're going to use the insulin pump as one system that will show us really how safety critical systems are crucial, okay, and how they work. Okay, so diabetes it's a common disease. It's a common disease about blood sugar. It's a common disease. I'm sure you probably know someone who has diabetes. And then so there's the insulin pump. There's the option of injections without using a pump, but then a pump is also another option. And the pump for it, it's really it calculates itself. Okay, it really calculates. It calculates when the blood sugar is low or high, and it will act accordingly in terms of delivering the insulin. Okay. Yes. But before I go on, maybe I can also just say more about this insulin pump. Okay. It has some advantages. The advantages, by the way, you can Google and see what it looks like. If you want to see more what it looks like. Okay. So its advantages, the users record a better quality of life. Report a better quality of life, I mean, compared to other methods. I mean, imagine you have to getting an injection, feel the insulin convenient. Okay. Rapid acting insulin, it acts faster. It acts faster. Okay. Then it uses really programs, so it is scheduled. It schedules itself. Okay. It is harder when you have to keep on you doing it yourself, scheduling yourself with the injections and so on and so forth. Okay. Yes, I've already talked about the convenience of it. Then also it is really precise because it calculates the parameters in the blood that it uses. Then it calculates exactly how much is needed. And remember, for it's calculating depending on, it knows that last time you used this amount, so this time, this is what is necessary. it will not, it's really more accurate. It's really more accurate. It will know, it has the history of what it last did. Okay. So it's more precise. Okay, then also depending on your sugar level and how much insulin is still active in your body, how much carbohydrates you've taken in, it will wisely look at all those and then do the correct calculations. Okay, we talked about the history. Okay. Okay, then maybe it also has disadvantages. Okay, they're not only advantages. Okay, it is something that needs to be worn. Okay, so you have to wear it. So it's also not, you have to maneuver it as you wear it within the clothes. It's not something so direct. Okay, and then there's nothing that is perfect because it can also malfunction sometimes. Okay, it can also malfunction sometimes. Then it has the needle. Now here, this is, we shall see this as we go on. Also, there's the needle. It has a needle that has to be inserted into the body. So because it can cause scar tissue, this tissue is also not easy to manage. So it's also not, and remember, for it, the needle is constantly inserted. Okay. Okay, so and it can be a risk of infection depending on, you have to of course be careful as you use it. And then having something foreign in the body all the time is not really a convenience. Okay, depending on your skin types, there can be reactions. Yeah, so it has its advantages. Yeah, you can generally read about it. It's also sometimes good to have more information on something and not just to study it abstractly. You know, you've studied about the insulin pump and then you have just something, but then you don't really know what it looks like. So I advise you Google it, see what it looks like, read more about it, just to give you a clearer picture, really. Give you a clearer picture. Okay, so we have talked. I've already talked about some of the things that I talked about, the advantages and disadvantages. Okay, the level of insulin the problem with this treatment is that the level of insulin in the blood does not just depend on the blood glucose level, but is a function of the time when the insulin injection was taken. I've talked about that. Okay, so the levels of blood sugar. This can lead to very low levels of blood sugar if there is too much insulin, or high levels of blood sugar if there is too little insulin. Okay, low blood sugar is also very dangerous. Okay, in the short term, a more serious condition as it can result in temporary brain malfunctioning and ultimately unconsciousness and death. Okay, long-term effects are also there. So this pump just tries to imitate the pancreas. Okay, just tries to imitate the pancreas. It uses a sensor, as I've already talked about. A sensor. It uses a sensor to compute the insulin dose. Okay, that you're going to need for the glucose. And they give a picture here of the pump, how it works. Really, this is it's a summary of how it works, and even on the next slide. Okay, there's the pump, there's the needle assembly. The pump pushes the insulin to the needle, and which delivers it into the body. The controller is through the sensor is going to determine how much insulin is needed so that it can direct the pump accordingly. You have the displays. Of course, you're going to see what is their number that needs to keep on displaying and so on and so forth. The time. Okay, there's the alarm, there's the clock, the alarms in case of something gone wrong. Okay, the alarms are important. This is really another diagram just to show it how the insulin flows. The blood The sensor senses some parameters in the blood. Analysis is done on the blood sugar. Then, depending on what comes out of the analysis of the blood sugar level, a computation is done of the insulin, and then the insulin, the controller then determines and instructs the pump on how it's going to, or what it's going to deliver. Okay. Yes, this here, let's explain further really what we've been talking about. I've already talked about the permanently attached needle. That's a bit of an inconvenience, a permanently attached needle. That's one of the inconveniences I talked about, and they also let's explain more there. Some of the dependability requirements. The system shall be available to deliver insulin when required to do so. So, availability. We talked about the availability being one of the dependability requirements. Reliability. Okay, you can see the second point, reliability. Okay. Safety. Safety. You can see safety. So you can, don't forget that, okay? Within dependability, we have availability, reliability, safety, and security. They will always come in at a certain point. Okay, that's why you see there are these points here outlined like this, but you can clearly see they're talking about availability, reliability. Let's see if any messages. That's fine. Reliability, safety. Okay, they're talking about those. Okay, of course, in some systems you may not talk about security because now like here you may not talk about security, but in some systems even security will come in. Okay. You shall see that now, like in computer systems where you have attacks by hackers, okay, and so on and so forth. Yes, but you can see that. So safety, for example, excessive doses of insulin should never be delivered, as this is potentially life-threatening. Okay. Availability, system shall be available to deliver insulin when required to do so. Reliability, the system shall perform reliably and deliver the correct amount of insulin to counteract the current level of blood sugar. So just don't forget that within dependability, even this is very clear here, you can see it's outlined to you. Within dependability, we have availability, reliability, safety, security. Okay, just try to understand that those four. Within dependability, we have they are called the principal dimensions: availability, reliability, safety, security. Okay, of which they define them there within in the diagram. Okay, they are redirects availability, the ability of the system to deliver system services when requested. Reliability, the ability of the system to deliver services as specified. Safety, the ability of the system to operate without catastrophic failure. Security, the ability of the system to protect itself against accidental or deliberate intrusion. Now, as you read this, please think about the examples I've been talking to you about. Okay? Security. I've talked about the example of the Jeep Cherokee that was hacked into on a highway by some two remote hackers. They did as a joke. Can I say like as a joke or a dare onto the company? But you can see there. So is it dependable? Is that Jeep Cherokee dependable? If its security can be breached in that way? No, it's not dependable. How much loss did they make at that particular time after that video went viral? How many people did not go out to buy the car? There have been recalls from cars. There have been recalls of cars because of simple safety measures not being taken. I think it was an airbag issue that caused some recalls of some cars. But yes, there have been recalls. So that one is now safety. Okay. If you think about you can think about the boat that sank on Lake Victoria. It was a catastrophic failure. So if it's got safety, the ability of the system to operate without catastrophic failure, but it was a catastrophic failure. So the safety there failed them. Okay. Reliability. The ability of system to deliver services required. Then availability. Availability. Now, when it comes to the example I can give you is now like within telecommunications, really. Systems have to be available 99% of the, that's actually normally the availability they measure is 99.98. Going below that is really, I don't know, it's kind of unacceptable, if I may put it that way. Okay, there's a time I was working on is a site I was working on in what the site I was working on, and then okay, so sometimes things can go wrong. So it went wrong, and then it took long to bring it back online. But the number of emails and the number of warnings that you get, and some of these companies really want their things done on the spot. Okay, they want some of their things done on the spot. So availability, very, very crucial. Very, very crucial. Okay. Okay. Okay, so the other dependability properties like repairability, maintainability, survivability, error tolerance. Those are also directly repairability. Okay, in case of a failure, okay, repair, how quick can it be repaired? Maintainability reflects the extent to which the system can be adapted to new requirements. Okay. Survivability, to which the system can deliver services whilst under hostile attack. Okay, and error tolerance reflects the extent to which the user input errors can be avoided and tolerated. Yeah, so these are others also important. Okay, also important. Repairability. Now, for example, that system I was working on, if it gave me a hard time, but then it was made in such a way that it can, because it was using Windows. I was working for, at that time I think I was working for MTN South Africa. It was using Windows. The base control station was using Windows. Windows is made in such a way that its recovery is not so, they try not to make it too complicated. Otherwise, if you're going to keep calls offline for 5 days, then there's something wrong with the Windows. The Windows, it is made in such a way that it's easy to recover, doesn't easily crash. So you have the system back online in what? In a short time. Okay. Okay, we have 10 minutes remaining. It's okay, there'll be enough for us to stop where we can stop today. Okay, we can go on. Dependability versus performance. Of course, dependability is going to affect the performance. That's what they're trying to explain there. It's going to affect the performance. Untrustworthy systems may be rejected by their users. System failure costs may be very high. It is very difficult to tune systems to make them more dependable. So definitely dependability affects what? Performance. That's all that they're trying to explain there. Okay. And then of course the costs. Okay. The dependability costs tend to increase exponentially as increasing levels of dependability are required. So you can see that in that graph there. Okay, as you want something to be more dependable, it's really going to be very costly. Okay, it's really going to be very, very costly as you want something to be more dependable. Of course, why? Because the development techniques they're using are more accurate, they are going to be more costly. Okay, even the customer who wants something to be proved is going to cost you. It's going to cost you more. Okay, I remember now, like whenever I would finish, maybe if a project is being completed. When a project is being completed, there is what they call acceptance tests, whereby you sit with the customer, and the customer is going to ask you, okay, now do this command. Is the call going through? What kind of call is it? By the way, I'm just giving these examples because it's the places where I've had experience, but then it can be really taken to anything else. Okay. I'm sure even when it comes to maybe any other systems, really, after you've finished doing a project, there are different steps in a project, by the way. There's the execution part. First, there's the preparation part, planning, and so on and so forth. Now, that's more project management. And then there's the execution, and then there is the what? Then there is the acceptance before it goes online. So during the acceptance, okay, you're doing vigorous tests to see that this system is actually going to work as it's supposed to work, but that's going to be costly. First of all, the systems you're using to do the tests, even the costs of having people on the sites, because some of these places, you have to keep people there. You have to take care of them, pay them, and that takes more time, okay? So the costs definitely will come in there. And then, okay, now, so within dependability, we said we have reliability, we have availability, we have security and safety. So for today, already defined reliability, actually. Here they just redefine it further. Okay, they just define it further here. So I'm not going to really read through this. I just already explained really what they are. Okay. But sometimes
question, but I saw it, but then I forgot.
Yes, sorry. Okay. So so availability can be taken within reliability. Okay. Sometimes really depending, you know, it's not something like A, B, C, D, F, G, O, 1, 2, 3. Nothing is just straightforward like that. Sometimes you can have systems whereby it is reliability that is determining everything, and the availability is under the reliability. Okay. You can have systems whereby the reliability is low, but when the system is available, okay, the system is available, whereby the reliability is low and the system is working with that low reliability. But when it's available, it can quickly take care of the problem and put it back before it causes a major issue. Okay. They're saying availability takes repair time into account. It does, and we shall see that later when we're seeing some calculations. Okay, that availability takes repair time into account. We shall see that with some calculations. Okay, then we have some terminology here. Failure, error, fault. Once an error occurs, it's going to lead to a fault. Okay, the fault will eventually lead to a failure if you do not take care of the fault. Okay, an error occurs, it will lead to a fault. Okay, and the fault will eventually lead to a failure. Okay, again, really the definitions you can read, but that's one thing you should know in your mind. Okay, an error will occur. It will lead to a fault if not taken care of. If fault not taken care of, it will lead to a failure. Okay. Human error, mistake, behavior that results in the introduction of faults into a system. Okay, faults and failures. That's faults and failures. Failures are usually a result of system errors that are derived from faults in the system. I talked about how the one leads to another. Okay. However, faults do not necessarily result in system errors. Okay, here they kind of mixed up, but then the errors lead to the faults, and the faults lead to a failure eventually. Okay. Errors do not necessarily lead to system failures. The error can be corrected. Okay, the errors can be corrected in time to avoid the failures. Okay, and that's what leads us to the last part for today. Reliability achievement. Okay, the way they try to explain them here, they try to explain, but something which I found a bit more clear was in this PDF. I'll also share this PDF. Let me share the screen of what I'm trying to talk about. Oh, where is it? Okay. Okay. I don't know if you can see that. So we have, so faults are related to hazards, okay? Here they talk about hazard avoidance, hazard detection and removal, and damage limitation. I found this explains better than the other one about those. So hazard avoidance. So you avoid the hazards. For example, I told you the example whereby use an operator, use a machine that uses both hands being occupied such that the other hand is not in the way of danger. Hazard detection and removal. For example, if an engine is going to blow up or it has fire, the system to extinguish the fire before it causes damage. Okay. Damage limitation. Sorry, that was damage limitation. That was damage limitation. But detection and removal may be like a valve. The example there is of a valve which releases pressure before the pressure gets dangerous. Okay. Damage limitation, the example is like the engine has caught fire, the damage has been there, but then it's extinguished. Okay, to reduce the damage. Okay, I don't want us to go beyond this for today. So we're going to stop here. I will share with Davis the PDFs and the PowerPoint. Okay. All right. Otherwise, please inform the others. The next lecture is going to be on Wednesday at I think it's 2 according to the timetable. Is it 2? Is it 2? The timetable?
Let me check the timetable, but it's at 2.
On Wednesday. So we shall, yes, it should be 2 on Wednesday.
Progress.
It should be 2 on, it's 2, eh? It's 2, eh? Okay. So the next lecture will be at 2 on Wednesday, still on Zoom, okay? We shall meet then, so I'll share everything. Okay, thank you. Bye-bye.